Chapter 4, Lesson 2, Slope of a Line. You're going to see that slope comes into play a lot in this chapter, as you can see. Slope there is in our standard 8 EE5, and then as we scroll way down, you'll be able to see that it's also down here in 8 EE6, where it says slope. You'll be able to find slope, and we're talking about using right triangles to show why m is the same, and talking about m, you can see here we're slope in our 8 EE6 as well. Slope is major, so let's talk about it. Slope is the rate of change between any 2 points. So any 2 points you pick on a line, the first and the last, the middle two, the first and the second, the last two, doesn't matter. It's always going to be the same for that slope. And this word ratio, remember, it's just kind of like the word meaning a fraction. A ratio is any number that can be written by division of two numbers. So here we have 2 points. Point 1, x1, y1, and then point 2 with some numbers, x2, y2, just meaning the first point has some ordered pair, 3, 4, and the second ordered pair, the second coordinate, has something else, 10, 12. From there, that's where you're going to see us here today. Every time, you're going to write out m equals slope equals, and then what we usually find that we like is this first one, rise over run, which I'll explain in a second. Otherwise, you can do this, which is called the change in y, subtracting the y's, over the change in x, subtracting the x values. Notice, just make sure you keep them in order. Here's your second point listed first, and then the first one. Otherwise, we're going to do rise over run. It's going to talk to us and say define or describe slope. These are what slopes look like, and this is positive slope because it's going up, and negative slope going down. But to help us remember that, in class I've drawn on a guy, call him my friend, Mr. Slope Man. Mr. Slope Man is a superhero. He's got a little issue, or he's got a unique thing about him where he can only go right. So as Mr. Slope Man is going right on this graph, you see that it is going up. So he's going up. He has positive slope. Over here on this guy, when you see Mr. Slope Man, who can only go to the right, Slope Man can only travel right, he has a negative slope. This graph is going down. It falls. Thus, it is negative. A slope of 0, well, it's just a horizontal line, but bringing in Slope Man, if he goes walking, notice he doesn't go up or down. Thus, the slope is 0. In an undefined slope, well, Mr. Slope Man can't walk on this line. He just kind of falls, and I bounce him around in class. But that's undefined. It is a vertical line because it's not either 0, it's not positive, or negative. It is undefined. Describe the slope. So Mr. Slope Man, who can only go to the right, when he goes walking on this, he is going to be walking up, which means we have positive slope. Done. Then find slope. Every time we have to find slope. Yes, every time you're going to write m equals slope equals, and then since there's a graph here, I'm going to use rise over run. Yes, every time we're going to write that out. Why? Number 1, I told you so. Number 2, it's a point. Number 3, it's a formula, so it's going to help us remember it. And number 4, we really need to grasp this concept that m is the same as slope. Not just now in this chapter, but in next year, and anytime we talk about equations, we need to know m is slope. Now, when we talk about rise over run, this is why a lot of people like this one. There's a graph here provided, so pick any 2 points. Hey, look, there are 2 provided for you already. Pick those 2 and go from one to the other. Mr. Slope Man goes from left to right, so I'm going to do the same. I'm going to start here at this point, and I'm going to journey to the next one. How much up do I go? 1, 2, 3, 4. I have a rise of 4. Again, don't count that first spot, just count how many you move. 1, 2, 3, 4. What do you want to call them? Dots or loops? Either is fine. And then from that first point, how much do you run from the first point to get to the second point? From right here, we go 1, 2, 3. 1, 2, 3. Count carefully. A small counting mistake brings a tear to my eye and a red pen out. We want to count very carefully. So then that's it. Now, because slope is a ratio. All we want to do is make sure that this ratio here has been as much reduced as possible. Again, what I mean by that, well, a lot of times we're going to see that and think to ourselves, oh, that needs to be 1 1/3, which is a very good mixed number. It is what 4/3 is, but a ratio compares two numbers. This has 1, 2, 3. So a mixed number will not work. Can you take anything out of both 4 and 3? No. Thus, it's reduced, and it is in simplest form as a ratio. Leave it as 4/3. Done. Here we go again. Describe the slope. Mr. Slope Man, going from left to right, you'll see that he's going to journey down, which means we're going to have a negative slope. If it says to describe the slope, describe it. Your options are positive, negative, 0, or undefined. Then it says to find the slope. Since it says to find slope every time, m equals slope equals, or you could rearrange those two if you'd rather write slope equals m equals, that's fine. But now, again, the graph is here, so I find most people really like this rise over run. So you must write that down every time. Yes, every time. You don't need to draw the graph in, but you're going to write this in, slope equals m equals rise over run, or m equals slope equals rise over run. We want to rise. Notice this time we're not rising up, we're rising down, so that's very important. Don't forget that, because as we're counting from this spot, we're going to see how much we went down. 1, 2, 3, 4, 5. Because we went down, please make sure that's a negative 5. It's negative because we went down. The slope is negative. And again, run from here to this point. 1, 2, 3, 4. Can you take anything out of both negative 5 and negative 4? No, you're done. Again, when you look at this standard, we're doing this because we want to find slope. You can put a little check there by that one. As we scroll down, here again, 8EE6, finding slope. We've been using triangles. I'm going to show that another time better about how we're using triangles to show slope is the same between any of them. But you can see now that we got that m comes to play here, down here, and here later on. So that's why it's so important that we remember that m is the slope. Find the slope of the line. That's all it says to do. So here we go. Slope equals m equals rise over run. Slope equals m equals rise over run. Yes, every time it says to find slope, you have to do that. Going from one point, Mr. Slope Man has me always going to the right. So from that point to this guy, how much did we rise? How much did we go up or down? 0. All right, cool. How much did we run from that point to the other one? So 1, 2, 3, 4, 5, 6. Count it again just to make sure. There you have it. Can you simplify that one? I'll accept that. I know IXL accepts it, but let's simplify it down. The slope is 0. Again, Mr. Slope Man neither goes up nor down, so it's just plain 0, which is a ratio because 0 as a fraction is 0 over 6 or 0 over 1. Find the slope of the line. Here we go again. M equals slope or slope equals M. I'm not concerned which way you write it, but then I do need to see the word rise and the word run. You can do the other one if you'd like, but again, we'll show that to you in the next example, and I find most people with these graphs really like that. In your textbook, please be careful that you don't mark it up with your pencil as you're counting the rise over run. I'm just going to pick the top one here, and now we talk about our rise, and we went down 1, 2, 3, 4, 5, 6, so down 6. And then how much did we move left to right with this guy? We didn't. It's just right on top of each other. So there's 0 run. Please make sure that you know that is a 0. If you have a calculator, quick, take -6 divided by 0. In class, I have you show this to you. The calculator says div 0 error. You cannot divide by 0. Anytime you have 0 on the bottom, key phrase, 0 here on the bottom, you're going to type it into a calculator and get an error because you cannot divide by 0. Which is why your slope is undefined. It's a vertical line, but we must be very careful. The previous example had a 0 as well, but when 0's on the top, you get a final answer of slope 0. Only vertical lines have undefined slope because you're dividing by 0. Sometimes they won't give you a graph. They'll just give you a table, or they'll give you 2 points. And whether they give you this table like we have in this example or any 2 points, you can still find the slope of the line. When we hear slope, we're thinking m equals slope. And we've been writing for a long time, rise over run, which again is what most people like because you just count on the graph. However, there is no graph here like we've had in our previous examples. I've had people in the past graph points and then do rise over run, but you don't have to do that. What we can do is then do the other option we had from the very beginning slide. That means instead of this rise over run, we want to focus on something different, and we want to call it the change in y over the change in x. I'm going to run out of space, so let me fix that quick. Now, that will work for your formula. If you remember back on the first or second slide, that's where I talked about y2 minus y1 over x2 minus x1. All it's talking about, again, is the rise over run, the change in y, which is subtracting your y's, over the change in x, which is just subtracting your x values. What x values? Well, that's a very good question. All you want to do is you want to pick 2 points from up here. Any 2 will work. If they give you 2 ordered pairs, then just use those up here. Pick any 2 you'd like. Class, I'd let you pick them, but for me, I'm going to pick 1, 1 and 0, negative 2 because they're smaller numbers. They're mostly positive, and I think it's going to make work nice for mental math. Now, for me, we talked about y2, y1. Why are those there? Just pick one. I'm going to pick this guy. I'm going to start with the ordered pair 1, 1. What is the y value in this first ordered pair? It is 1. Minus, now what's the x value in this first ordered pair? That goes on the bottom. Notice how I put those pairs right on top of each other. And then we go back. Now we're going to focus on our second point. So whether you see it written like that or you see it written as an ordered pair, we're going to focus in on those. And we're going to look at this one. What is the y value in this point? It's a negative 2. And what is the x value in this second point? It is 0. And now we're going to go from there. Please remember, if we're using mental math, careful, we're going to do the don't subtract, add the opposites. That way you can see it is 3 over 1, which will simplify, and I'm going to move that over here underneath the word slope, to just plain 3. The slope, where m is 3. As you look, you could do the same thing. We talked about slope as rise over run. The change in y. What is the change in y? Well, we are going 3 or up 3, the rise. And then what is the run? How much is our x value changing as we go across the scale, as we go across all our points? They are going up by 1. So you could still do rise over run in a table. I just need to see the work, and I need to see the formula. Whatever you're going to use for m equals slope, and then give me your final answer. Again, we were doing that because we're talking about our equations that we want to be able to look at and graph, and then scrolling on down, you can see we've got our slope that we use multiple different times. Today, finding slopes of lines using 2 points or just from tables, whether they're graphed or not, that is the goal.